this video, we are going to be looking at linear programming. And linear programming was developed by Dr. Danzig in 1947 after Second World War. And Dr. Danzig purposely developed this linear programming to solve the problem of optimization. You should know that when we're talking about optimization, it's divided into two. It could be minimization or maximization. By maximization, it means that we are looking at the number of units of output which a particular available resources can give us. And when you are talking about minimization, you are looking at a situation whereby, for instance, you are looking at how can you minimize cost of producing a particular commodity. Now, I need to let you understand here that if you are solving the problems of optimization using linear programming, you need to understand three aspects of linear programming. The first one is the objective. You need to state your objectives. Don't forget I said when you talk about optimization, it could be in two ways. It could be maximization or minimization. So you need to state it, the one you are working on. Is it maximization or minimization? That's the first one. That is the objective. Then number two, the number two aspect is that you need to state the constraints. That's resources you have, the limited resources you have. You need to state it. Then the third one is the non-negativity of the constraints. That is, you should know that even with this scarcity of resources, your S cannot be negative. Your S can be 0 or greater than 0. That is, the output which you are going to have will be 0. It can be 0 or greater than 0. Now, among the methods we can use to solve the linear programming is graphical method. If you are using graphical method, you should note this, that you can only use graphical method when you have two variables. When you have more than two variables, graphical method is not suitable. I said it again. Graphical method is not suitable when you have more than two variables. Look at the question on the board here. A firm produces two products X and Y at a price of $4 and $1. This firm produces two products X and Y, and this X is sold for $4 after production, and Y is sold for $1 after production. That is the prices. Now, to produce this X, you need two inputs. Like if you want to produce bread, you don't just need only flour. You need margarine, you need yeast and some other things. Now, for these products, we don't need 3, 4, 5 units of inputs. What do we need? We just need two inputs. We need inputs B and A. To produce X, the firm requires 1 unit of input A and 3 units of input B. So when we have 1 unit of input A and 3 units of input B, we will definitely produce 1 X. And to produce Y, we require 1 unit of input A and 1 unit of input B. But don't forget, we don't have all the inputs to produce for the whole world. Then, total available inputs in each case are 50 units of A. It means that we only have 50 units of A and the 90 units of B. Now, don't forget, I have told you the three aspects that you need to state if you want to solve the problem of linear programming. Now, can somebody tell me there, what is that? The first one, objective. Yes, you need to state the objective. You need to state the objective, and what do I mean? The objective can be minimization or maximization. But the question here, we are trying to look at the revenue. We are trying to look at the total revenue we can get from these limited resources. So we write it this way. That maximization, that is the first objective. That's our objective. That 0 represents the total revenue equals 4, which is the price multiplied by any amount of X we produce, plus 1, which is the price of the Y multiplied by any amount of Y we produce. This will give us our total revenue. But don't forget, we don't have all the X of the world and all the Y of the world. We don't have all the A inputs of the world and all the B inputs of the world. We are constrained. We only work based on the limited resources we have of the inputs A and input B. And that is why we are subject to this constraint. This is number 2. Aspect number 2 of linear program that you need to state. Now, how do you do this? Sometimes you'll be given a question like this. The maximization or minimization will be stated, so the constraint will be stated. But when you are given a one problem like this, you need to go back to the question to state all of this. And that is exactly what I've done for the maximization. For the subject now, the constraint, number 2 aspect. How am I going to write this? Now, I go back to my question. To produce X, the firm requires 1 unit of input A. So I'm starting from input A input. I will write my 1 I need 1 to produce 1 unit of input A to produce X. Then I need how many units of input A to produce Y? You go again to produce X. The firm requires 1 unit of input A. To produce Y, the firm requires 1 unit of input A again for the Y. It's also 1. But you know in mathematics, I don't need to write this one. I don't need to write this one. And don't forget, this input A, all of what we have here, we cannot use more than the available resources, which is input A. That is why you put the inequality sign. Then, for the input B, this is the second one here. For my input B, which is the second row, then I go again to produce X. The firm requires 1 unit of input A and 3 units of input B. For the X now, it's going to be 3 units of input B for the X. And for the Y requires 1 unit of input A and 1 unit of input B. Then 1 of input B for the Y. And the total resource, so the available resource of input B we have is 90. That is the constraint. That is the second one. Then the third one is the non-negativity, that your X you are producing can be 0 or greater than 0. And Y can be 0 or greater than 0. Y can be 0 or greater than 0. It can never be negative. That is the 3 aspects we have stated. Now let's quickly use our graph because we are using graphical method. To get your to plot your graph now, let's take the first one here. But we must convert this to equality, not inequality now. We convert it to equality. I can just have X plus Y equals 50. So I'm assuming that this X is 0 first. So if X is 0, my Y will be 50. So if X is 0, this is my X. When it is 0, my Y will be 50. Somewhere here. Now, let me now assume that I write again X plus Y equals 50. My Y is now 0, so my X will also equals 50. So when Y is 0, my X will be 50. So these 2 lines, I join it together, use your ruler, don't forget, use your ruler to do that. Use your ruler to do that. So that is the first thing you do. After you have done this, for the A, you go to the B, go to the row B. Then again, 3x plus y equals 0. Let's say x is 0 here. If this be 3 times 0, that will be 0. This one will be, okay, this is 90. Then we have y equals 90. So when x is 0, y is 90. Our 90 is somewhere here. So we can stay here. Okay, let's use the second one. 3x plus y equals 90. When y is 0 now, then we are having 3x equals 90 by 3 by 3, divide both sides by 3, x will give us 30. So x will give us 30. So when y is 0, our y is 0, x will be what? 30. 30. So I draw the line to join the two together here. The 2 together here. Are you getting what I'm doing? Now, having understood this now, after we have done this, then the next thing for us to do, is to get our principal region, the possible output we can produce. Now, then look for the one from this point now to the origin. It has a shade now, so we can just shade it like this, like this, like this. And you see, we don't go beyond this line, so we only maintain the ones that have this enclosure is here. You can see it, the enclosure to the origin here. So now we can have these points now. Let's say point C. Let's say this is D. Let's say this is F. So these are the 3 points now. These are our corner points. So you can simply draw your corner points if you like. Let's say I draw my corner points this way. And let me put my corner points here. Corner points. Corner points. Then I can put my subject here, mark the red value here. which is 4x plus y. So my first corner point, I can take, look, I'm taking from here now. I'm taking from here. When my x is 0, I'm looking at 6df now. So from the C now, when my x is 0, my y is 50. X is 0, y is 50. Please look at what I'm doing very well. When my x, I take from the beginning, from this one, and this point indicate that when, for us to get this point, it means that our x is 0, our y is 50. Then for the second one, here we can use two methods, but we can use linear, we can use simultaneous equation when you have intersection like this. You can use, but let's solve the one that is not intersection for. There is no intersection here. So for this point now, how do we get this? How do we get this f now? How do we get the f? Can someone tell me? It means that when our y is 0, our x is 30. This point now we get it because when our y is 0, our x is 30. When our x is 0, our y is 30. Our x now. When our x, am I right? When our x, this one is, when our x, how do we get this? Okay, our x is 30, when our y is 0, when our y, let's say this is x, this is y. The first one we did, x, when our x, for this point, our x is 0, our y is 30, our y is 50. Now when our x is 30 now, our x is 30, x first, x is 30, our y is 0. Our y is 0. Please look at what I'm doing very well. X first. X is 30, our y is 0. Then this third one that we don't know, we can simply do the simultaneous equation for intersection. Anytime you have the intersection like this, the point, you can use your ruler, but when it is sketched out like this, you can use your, you can also use your simultaneous equation to get the answer. So for this now, the equation that gives us this, is this b, which is 3x plus y equals 90. And the equations that give us this, that give us this one is x plus y equals 50. Now, so when you want to find the simultaneous equation, the upper one, you can see this is the upper one, followed by this one. You can see the height. This has more height than this. So the one that has the upper height become first in your simultaneous equation. Anyone that has, you can look at the difference between this point and this point. Any line that has the upper height, you write first. So I write my 3x plus y equals 90. Then for the second one, x plus y equals 50. I'm solving the simultaneous equation. Please look at what I'm doing very well. It's just very simple. I'm trying to solve the simultaneous equation, using simultaneous equation to get my coordinate for this intersection. So I can simply say that here, multiply by 1, multiply by 3, this will give us 3x, this will give me y, this will give me 90. 1 times 3 is 3, 1 times y, 1 times 90, 90. Then this 3 times x, 3x, 3 times y, 3y equals 3 times this will be 150. So when I do it now, this will go away. Then I'll be having here minus 2y. Then this will give me minus, if I'm correct, minus 90 minus 150 minus 150, that will give you minus 60. Minus 60. Yes, that will give me minus 2, minus 2. Minus the y will be 30. So the y will be 30. Y will be 30. Then my x. So since I know my y, I can say x plus y equals 50. Then x, I don't know x, but y is 30 equals 50. X equals 20. So my x will also be 20. Now, finally, so I can now look for the one out of all these corner points that will give me highest, revenue. Then I can just say that, okay, my z for this place is 4 times 0 plus y, 50. This will give me 4 times 0 is nothing. This will give me 50. Then for this one, 4 times 30 plus y. My y is 0. My y is 0. So this will give me 4 times 30. This will give me 120. Then this will give me, okay, this will give me 4, the 4 here, times x. My x is 20 here, plus 30. My y is 30. So this will give me 4 times 20, 80. 80 plus 30. That's 110. That's 110. Am I right? 4 times 20, 80. 30, which is y. That would be 110. So which one gives us highest? So this one gives us highest, highest. So if you can produce 30 of x and 0 of y, that is when we are going to get highest revenue. That is when we are going to get highest revenue. Please subscribe and get more of our video. Thank you. That is how to solve linear programming using graphical method. Thank you.